continue our learning series in C, and this time we'll be looking at basic concepts on how we could just use GCC compiler and write some basic codes. Now, the very first one we're doing is running a C file through the preprocessor. Now, first things first, let me create. Okay, then let me create a test file. Let me call it C file. C file.txt. Just going to make some documentations. Let me just write a C program that basically prints C's font. Yeah, let me just do that. Just be simple C program. Then we're going to put /n for a mainline character. So I'm done with creating my C file. Now our very first step here is running a C file through the preprocessor. Okay, now for me to compile my code I have to use the GCC compiler. Now you can also use the C lang compiler, but then I want to use my GCC, which is the first thing. I'm going to compile this code, but then we know that the compilation of the C program are in four phases: the preprocessor, the compiler, the assembler, and the linker. So if I want to compile this file through the preprocessor, how am I going to do that? Well, I'm going to do that with flags. So the first thing, because just doing GCC then passing in my C file to it is basically going to work, but then it's going to create an exe file or a binary executable file, and then I don't want that. Well, let's do that. You can see it's done. If I do an ls, you can see my executable there, 8 or out. Now let's assume I want to do a full linking, which is this part here. I want to do a full compilation, which is this part here. I'm basically going to do this. Yeah. Now what if I want to do a full compilation, but then I want it to save to another output file? Like I want the output, because by default if you don't put in an output file name, by default for a Linux system it's going to give you an a.out file, of which you can then run this way. You can see it's fun. So I can come back here and recompile, pass in the flag O, and it says AB, and then now you can see AB. Now if I'm going to run it again, you can see it's exactly same. So if I want to save to an output file, I'm going to pass in the flag O, and then what follows it should be the name of the file you want. So I'm just going to remove the dot out. Confirm, you can see it's no longer there. Now I want to compile this particular C file through the preprocessor. So I'm just going to do gcc -e, then my C file. Now if I don't put in an output file, let's say preprocessor, if I don't put in an output file, it's just going to dump this to my screen. Just basically going to dump this to my screen, and it's really going to be a very long. Well, let's see. Now you can see these are running my C file through the preprocessor. These are the results that it came. You can see some you can see a bunch of stuff here. Now let's assume I want to save this now to an output file called preprocessor. Going to run down. I'm doing an ls. Now you can see output file here, the preprocessor. So let's go back to the next one. Now, so if you run, what if I want to run a C file that compiled but does not link? Okay, meaning I won't generate I won't get to the linking part of it. I'm just going to pass through the prior 3 stages, and then I'm going to stop there. Now how am I going to do that? Well, still same. Like I can see, it's the same C file we've been using that we created. Now I can basically do that within gcc to actually create the object code, then pass in my C file. Now if I don't put in an output file, it also has in a default file that it's going to return. Now let's see. Okay, it says if linker input file unused because linking not done. Oh, sorry, I missed it. .c here. Yeah. So you could see, though I'm running into an error, but then I'm just using the name of the error that was being returned back to me to actually get my way around it. Now you can see I didn't pass in an output file name, but then it returned this to me, and then I can view what is in it. And you can see it's a bunch of stuff. Okay, now what if I want to generate an assembly code from a file that's from this from this same C file we just wrote? How am I going to do that? I'm going to use my gcc, but then I'm going to pass in the I'm sorry about that. gcc -s, and then my C file. Same thing with this. If I don't put in an output file, is also going to return a default file. Now let's see. Now you can see returns the default file. I can still do this. First let me remove C file.s. I can still do this and do C file.s, and it's still going to give me the same value as though I didn't. So if you still want to use the same file name, like cipher, but then with a different extension, then you can put in the dot. You can just leave this part out of it. But then if you want a different file output file name, then you can do this, and then let me call this output. Yeah, I'm going to see output. Let me put a knife in here, or rather an underscore. Now if I do an ls, now you can see it there. So I'm just going to remove that. Okay. So let me see our outline. So we're done with running a cipher through the preprocessor, running a file that compiles but does not link, which we have done by creating the object file. I've generated the assembly code from a file, which we just did with the .s extension, full compilation, which we did with the ABA, which is now an executable. Okay, now let's use some output functions in C, and then in the same file we'll also be using the using the size of operator in C. So we're going to go back to the C file. Let's see. Okay, now we'll know how to use the printf statement. Now the next statement we'll use is what? The putx. Now these functions are declared in this header files here. So that's basically the reason why I'm using it successfully. Now if I don't, just watch, if I don't include these header files here, now this particular file that has been compiling successfully will no longer compile. You get an undefined reference to printf. So now let's see. Just go to the last GCC statement. Now you can see this is the same C file that actually compiled successfully in the previous time, but then because we've modified the file, it's no longer compiling because we have removed the header file in which this printf function is being defined. So I'm just going to put that in back there. Okay, so quickly we'll use the printf function. Now let's use the puts function. Now let's see the man page for puts quickly. Okay, it's declared in the stdr.h header file. Okay, it takes in a string. Okay, so basically I can pass in a string literal directly, or a string variable itself. So cool. I'm going to go back to my C file and do process. So to use a string, we use a double colon. While for a character, we use a single colon. So basically, I'm going to use a double colon. Then let me just say Sammy King is loving C for programming language. Okay, Mr. G there. Now one of the perks of using the putx function is it automatically adds the \n to it. Now unlike the printf, in which it's optional, like if I remove this \n, it's going to print it on a new line. It's going to print on same line, and then the my prompt is still going to be on that same line. But then if I put in this backslash n, it's going to print this statement, and then this new line character is going to be printed, shifting my prompt to the next line. But then with the protest, I need not to pass in this. Subsequent video we'll be discussing in-depthly on using the printf function, then we can do some formatted printing out. Okay, so the putters basically by default adds in the backslash n. So let's compile and then let's see. So we're just going to do a full compilation. So cfile.c. So because I didn't put in an output file, now I'm going to get an a.out executable. Remember, ab is coming from the first c is fun. So a.out. Now you could see C is fun, making is loving C programming language. So the protest function automatically adds that backslash n to it. Now, what if I don't want to use the protest or the printf? Now I can actually use the write function. Now the write function is actually a system call, but then to use the write function we have to include some header files, but then send a message to nope, this is not what I'm looking for. Okay, yeah, this is what I'm looking for. Now for me to use the write function, I'll have to include this header file. Now this is the prototype of the write function. Now it's going to need a file descriptor, it's going to need a buffer to hold the data that is going to write, and then the number of bytes. So I'm going to include the unistd.h header file, and then it returns is a size underscore t data type, basically the number of bytes it actually wrote. Don't worry, we'll discuss this when we get to functions. So that's basically going to close this, go back to my C file, then I'm going to include it. Now hash include is actually a macro. Okay, now that is done, now I'm going to be using my write function. Now I'm going to be putting in one to indicate my standard output. Then I'll have to put in my message, which is a string because it's more than one characters. Then I have to put in the number of bytes that I want to read. But let me just say 120. Now if I pass in 120 and I ended up writing 150 characters, because it's going to count it in characters. Remember, in C, characters is 1 byte. So if I'm passing in 120 and then I'm writing, and on my buffer here I'm passing in 150 characters, it's just going to read 120 characters and then returns it back. But then if I'm passing 120 and then I am reading, if I'm putting in 120 as the maximum number of bytes and then I am putting 50 characters, I'm just passing this. Now if I'm going to count this, is definitely way below 50 characters. So because what I'm passing here is less than it's less than 120, it's going to return, it's going to read it. But then if I'm going to declare the size underscore c data type, and let me call it the c right, then I'm going to give it an initial, or let me just declare it. Then I'm going to be using this, and then I do this. Now you see that because this guy returns the number of bytes, right, it's going to return the number of bytes here, not here. Are we clear? Or we'll come back to it. Let me just remove this. Let me remove this. And okay. So yes, we're done. One for the standard outputs. Learning C programming is fun, no stress. Our string 120 is the number of bytes want to read. Okay, alright, that's cool. So let's compile. So GCC, okay. 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 Alright. Okay. So I'm just going to do size T. Call it bytes. 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 Then what's the next error? Okay. Looks good. Okay, so now if I'm going to run the a.out file, now you can see it says Sammy Kings. This is it from the printf function. This is it. Sammy Kings is loving C programming language from the protest function. Nice. You can see saying learning C programming is fun, not stress. Now you can look closely. Now it's printing C is fun, Sammy Kings is loving C programming language, and a whole bunch of other stuff there to actually complete that my buffer there. But then if I'm going to shut this down, to go back in here, and then let me just count it. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 23 34 35 36 37 38 39 40. Wow, we're going to reduce it to 40. To save it with right. Now you can see C is fun. Sammy Kings is loving C programming language. Now you can see learning C programming is fun, not stress, which it stops here. It's no longer filling this up again. Now you can see by default the right function doesn't put in the new line character. That's why you can see my prompt here now. So if you notice, vagrant at vagrant Ubuntu Trust 64 is my prompt, which I just basically put in a return key to actually make it look clean. Now to kind of make it more presentable, I can just come down here and then do a printf statement and just do this. Let's do /n. And now if I recompile with the same right function and then I run, now you can see everything looks much more pretty. Then something dropped in me, so let me just try it. Let me try it out. Try this out. Let's see. Aha, yeah, I suspected that much. Okay, yeah. Okay, so I think we are done with. I think we are done. Oh no, we aren't. We need to use the size of. Alright, so the size of basically actually gets the size of a data type in C. Get the size of a data type in C. Okay, so I'm just going to do this here so I can alright, so actually I demarcate it. Okay, so now size of operator is actually used to get the size of a particular variable for a particular data type in C. And in our intro video we were able to know the different data types available in C. So now let's say I want to print, now let's say I want to know the size. Let's say I want to know the size of a character. So I can say, I can pass in my string literal here. Size of putting chart. Then it's going to return an integer. So I can put in this 100% D, then backslash N, size up, then just put in int. Okay, so I'm just going to copy this out because I'm still going to replace them. So I'm going to change it to char, change it to int, change it to int, make another one, then change it to float, change it to float. Now the reason why it's best for us to use the size of operator, because depending on the machine in which your program is going to be running on, the size of the particular data type varies. For a 64-bit machine, the size of an integer is 4. For a 32-bit machine, the size of an integer is 2. Now you can see the variations. So it is very so if you're writing a program and then a program needs to run on a particular size, remember C is more or less dealing with memory allocation, dealing with hardware resources, and memory is a very important resource that we ought to make good use of. So if you are writing a program and then you are just putting in, and then you need to work with the bytes, like you need to work with some memory. If you are just putting out, as assuming you're on a 32-bit machine and you're just putting on 2 bits, now it's no longer portable, because when that program is being taken to someone that is using a 64-bit machine, it might actually run into some abnormality. That's why it's much more better to just use the size of operator. So then it just gets in the actual size of the data type based on the user machine. So I'm basically going to just compare, and then I'm going to tell you guys some drawbacks a little bit of me using %D, because if I'm going to be using %D, I'll have to just run it, like I'll just have to compile it like that without putting in more flags. But then if I'm passing in flags, I have to change it to %LD, signifying long double. Okay, so signifying long integer, sorry. But then that's going to go back there, and then I'm just going to recompile. Oh yes. Okay, so you see long unsigned int, so I'm just going to put that in there. Just going to put that in there because why? This guy returns an unsigned integer that is long. Remember, we have signed int, unsigned int, long unsigned int, long signed int. So that's the reason why you have to pass in the L %LD. Now to actually get a way around this, let's assume I want to still use %D. I could actually come in, but first let's compile. First let's compile first let's compile. Oh dear. So here shouldn't be scared of errors. Just kind of read the errors and then you know how to navigate your way around it. So like so, I'm done. Now you see, based on my machine, the size of character is 1, size of integer is 4 bytes, size of is 4. It's 4 bytes. But then if I don't want to pass in this guy here, I can actually do this. That's going to say basically come in here and do int a. I think I'm much more better like this. And then to actually declare multiple integer variables of the same data type. So I can't come here and do, because I want A, B, C to be of same data type of int. That's the reason I'm basically doing this. If I don't want that, I have to break it down multiple lines. Then I'm going to come in here and do A size of the character, then B size of int, then C size of float. Okay, and like so, we're done. Just a second. And that's going to run. Now you can see it's run successfully well. So let's see if we're done with our outline. Yeah, we're done with our outline. And yeah, there's this guy called Betty, which has been giving a lot of us problems. So in the next series, I'll be talking on Betty errors and then how to solve Betty. Alright guys, thank you.